Please ensure you have the correct writing equipment with you and your class books in front of you. As you make your way through the video lesson, take clear notes. For the Your Turn section, show full workings with your model question. Listen to instructions, pause to complete work, continue and mark work. Ask your classroom teacher for support if needed. So today is the second lesson on angles or angle properties of polygons. So ensure you get the main title down along with the date you are completing the lesson. From last lesson, we know that interior angles are marked as shown on the picture on the screen, and we know what an exterior angle in a polygon is as well, and it's marked with the double lines as shown in the picture on the screen. We also know that for any polygon, the interior angle add the exterior angle equals 180 degrees, as it forms a straight line. The exterior angle of any polygon add up to 360, regular or irregular. We learned that all exterior angles add up to 360. Remember, exterior angles essentially are making a full turn around the polygon, therefore it adds up to 360 degrees. And last but not least, two formulas we should have remembered or written down and we used last lesson. To work out any exterior angle, in a regular polygon, you do 360 divided by the number of sides. And to work out the number of sides in any regular polygon, you would do 360 divided by the exterior angle, one exterior angle. Remember, these two last formulas are for regular polygons. This lesson, we're going to move on to looking at irregular as well as regular polygons. Before we move on, we need to remember some notation. So when I refer to n throughout this entire lesson and in the future when you see the formula that you're about to learn, n in terms of polygons and angles equals number of sides. For example, for the triangle on the left hand side, n equals 3. That means there are 3 sides. N is just the number of sides. There are 3 sides. And you also know from our previous lesson that the total of the interior angles in a triangle is 180 degrees. That just means that that angle at that angle at that angle is 180 degrees. So n, number of sides, you know the total in a triangle is 180 degrees. For this one here, it's a quadrilateral, so n equals 4. There are 4 sides, that's all that's saying. And the total for angles, interior angles in a quadrilateral is 360. So again, this is something you know from our previous lessons. We're now going to look at interior angles in other polygons, regular or irregular. Before we go on, can you guess what the angles add up to in a pentagon? And how can we prove it? So just have a think. Using the information I have on the screen, do you think I can work out how many angles are in a pentagon? Or what the angles inside a pentagon add up to, not how many angles there are. There are 5 angles. What they add up to, and how can we prove it using all the information we have on the screen? Okay, now that you've had a think, or you might have written something down, I will now go through and explain to you how to find the sum of interior angles in any polygon. That means all the interior angles added together. Sum means all of them added together in any polygons. The example I have on the screen is a pentagon. As you can see with all the curved lines are representing the internal angles. In a 5-sided shape, there are 5 internal angles. So let's have a look. Any polygon can be split into triangles. Okay, so we start on one corner and we connect it to another corner or vertex. We call a corner of a polygon a vertex. Start from one vertex, connect it to another vertex, you make one triangle. As you can see on this one here, we started on this vertex here. So you always start on any one vertex and we connected it to another vertex, another corner, made one triangle. And then I went from that vertex, connected to another one and made another triangle. That's all I can do. If I went to another corner, it would just be this edge here or this edge here. So you can see from this polygon, so from the pentagon, we have made 1, 2, and 3 triangles. Okay? Notice that the angles combined in the 3 triangles are the interior angles of the pentagon. So this little point here is very important. Can you see, if I look at triangle 1, this angle here, this angle here, and this angle here is in triangle 1. Okay? Let's get a different color. I look at triangle 2, it's this angle here, and this angle here in triangle 2, the internal angles we're talking about, and a different color for triangle 3, this one here, and this one here. Do you notice that all of the internal angles in a triangle are also the internal angles of the pentagon? So for this one, all 3 angles in the 3 separate triangles are one interior angle in the pentagon. Down here, the 2 angles in the triangles are one of the pentagon. 2 here are one of the pentagon here, and these are just already the same size as what they are in the pentagon. We already know that the sum of interior angles in a triangle adds up to 180. Okay, so triangle, we know the sum is 180 degrees. We have 3 triangles on the screen. So if we know that in one of these triangles, the interior angles add up to 180, all we need to do is 180, add 180, add 180, as we have 3 triangles, or 180 times 3. And that will tell me that the answer is 540 degrees. Therefore, the interior angles in this pentagon, the total, the sum of the interior angles in this pentagon is 540 degrees. Okay, so just to talk through that one more time, internal angles in this triangle are also combining to form the interior angles in a pentagon. This little point here that I just mentioned, this little coloured annotation show me why. So I had a look here and I saw that, just bring my laser up, I saw that this part, and this part of the 3 separate triangles, they combined to make the whole interior angle of the pentagon. Okay, so if we split it into 3 triangles, we know the interior angles in one of these triangles is 180, 180, 180. To work out interior angles of the whole pentagon, we just do 180, add 180, add 180. 180 times 3 is the 3 triangles. Therefore, interior angles in any pentagon add up to 540 degrees. I've used information I already have of interior angles in triangle, and I've applied it to this shape and worked out what the sum of the interior angles in a pentagon is. Interior angles in any pentagon is 540 degrees. What do you notice about the number of sides in this pentagon and the number of triangles we have? Something you may have noticed is the number of sides in the polygon was 5, the triangles we made was 3. Okay, so the number of triangles we made was 2 less than the number of sides. In general, therefore, we say as a formula, the sum of the interior angles in any polygon is 180 degrees, which is one triangle, multiplied by n minus 2. N is number of sides, take away 2, where n is always number of sides. This tells you why. Notice that the number of triangles we can form is always 2 less than the number of sides. For the pentagon, it was 5 take away 2 and it made 3 triangles. If we have a look at a quadrilateral here, 4-sided shape, you can make 2 triangles. Pentagon, 5-sided shape, you can make 3 triangles. Hexagon, 6-sided shape, you can make 4 triangles. Heptagon, 7-sided shape, you can make 5 triangles. And octagon, 8-sided shape, you can make 6 triangles. Therefore, the number of triangles you can make inside the polygon is always 2 less than the number of sides. Make sure you write this main formula down, this black box at the bottom, and then you can also draw these images at the bottom here, which explain what or why this works. So in general, the sum of interior angles in any polygon is n 180 times n take away 2. Okay, have a look at the diagnostic style question on the screen, and once you have answered the question, come back to the video. It says, which of these diagrams best illustrates why the sum of angles, interior angles in a hexagon is 4 times 180? So the answer would be D. The reason why is the way we split any polygon into triangles, it was we start on one vertex, as I showed before, and connect it to another vertex. That's the only way we can make these triangles, okay? They need to connect to the vertex. And you can see you can make 1, 2, 3, 4 triangles. So it's 4 times 180. This one here, we actually have 1, 2, 3 triangles here, and then we actually have a quadrilateral, quadrilateral, and quadrilateral, and that doesn't work, and it's giving me angles in the middle here. I don't want any angles forming in the middle. If you look at all of this, all the angles for these triangles are forming on the vertex of the pentagon. Okay? No angles are forming in the middle of the shape. Same as this one here. There's angles forming in the middle, and here angles forming in the middle. All the angles need to form on the vertex of the original shape. Okay, I'm going to go through one worked example, and then you're going to have a go at the question on the right hand side. It says, work out the sum of the interior angles for a polygon with 6 sides. So that's part A. And part B, calculate the size of one interior angle in a regular hexagon. So we're both going to have a look at part A. We know the general formula for working out the interior angles in any polygon is 180 multiplied by n take away 2. In this case, our n is 6, so we substitute in the 6. N is number of sides, 6 sides. Therefore, it would be 180 times 6 take away 2. 6 take away 2 is 4. 180 times 4 equals 720 degrees. Therefore, interior angles, or the sum of interior angles in this hexagon or any hexagon, is 720 degrees. Part B, calculate the size of one interior angle in a regular hexagon. You know that in a regular hexagon, if we draw an example on the side here, all angles are equal. If all sides are equal, all angles are equal. So, if there are 6 angles in a regular hexagon, which there should be, you would just do 720 divided by 6, and it would give you one angle equals 120 degrees. Remember, you can only divide by 6 to work out one angle if it's a regular hexagon, as you know all the angles are the same. Okay, the question has appeared on the right hand side. Have a go at this question. Once you have done that, come back to the video and we will go through it. 7-sided shape. I've given you the formula. If you should start your first line with the formula. So for part A, it told you to work out the sum of the interior angles. You know the formula is 180 times n take away 2. Substitute in the 7 to the n, number of sides. That would give me 180 times 7 take away 2. 7 take away 2. Remember to put that part in brackets. You need to do the subtraction part first. So always put that in brackets. Remember BIDMAS. 180 times 5, which is 900 degrees. So the answer for part A is 900 degrees. And then size of one interior angle in a regular heptagon. Regular heptagon, 7 angles, equal sized. So we do 900 divided by 7, which would give me, to one decimal place, which is what I asked, 128.6 degrees. Ensure you mark in a different coloured pen as always, and any workings that you did not understand or did not get, make sure you copy it down in a different coloured pen. Okay, copy and complete the following table. What is the interior angle for each polygon? Therefore, what is the sum of the interior angle for each polygon? So total interior just means sum of interior, just remember that. And therefore, what is one interior angle for each regular polygon? Remember, this is saying regular polygon. So I've done some of them for you. Copy and complete the full table, and the question marks are the bits you have to do. Make sure that you write these in different coloured pens so you know which part to mark. I have put the formula in the top right corner as well, so write this at the top again to use it as a guide. And once you have done that, spend no longer than about 3 minutes, 3 to 4 minutes. Come back to the video and we will go through it. Okay, first question mark, Pentagon. Total is 540, so you do 540 divided by 5 is 108 degrees. Octagon, we would do 180 times 8 take away 2. 8 take away 2 is 6. 180 times 6 is 1080. And then divide that by 8 to get the one angle. And we did the same sort of process for the 9-sided shape and 10-sided shape. So if you haven't got this written down, if you ran out of time, ensure you copy the full table down in a different coloured pen. It says a little tip on the start as well. Memorize these for the pentagon, hexagon and octagon is good for a 5-sided, 6-sided and 8-sided shape. You know what the interior angle is. It will help you a lot in the harder GCSE style questions. Okay, there are 6 questions on the screen. I would like you to spend about 3 minutes. Do as many of these as you can. It does not matter if you do not finish, or even if you finish 1 or 2. Ensure you show your full workings. Once you have done that, come back to the video. Okay, the answers are now up on the screen. Make sure you mark in a different coloured pen as always. You were doing the same process as the previous 2 questions. Just make sure you were identifying that anything that's not written but that has that little squares and 90. Work out how many sides there are. Use the formula to work out the number of angles in that many sides, or use the table you already have. You don't need to do it again. You've already got that table written down. So for the first one, it's a 1, 2, 3, 5-sided shape. So you know interior angles in a 5-sided shape. Add the ones you have. Take it away from interior angles and it gives you X. Okay, deep in its style question. The diagram shows a regular hexagon. Find the value of X, show clear workings. So use the information you have on the screen, think about all the other angle facts that you know, have a go. Once you have done that, come back to the video and we will go through it. Okay, let's have a look at this question. So we know 2 things. It's a regular hexagon. So we know the interior angles of a regular hexagon add up to 720 degrees. So interior sum Okay, so the interior sum of the hexagon is 720 degrees. Remember, it's just 6 take away 2, which is 4, times 180, which is 720. We also know that interior angles in a triangle add up to 180. Why am I using this information? Well, you can see over here there's a triangle. Okay, I'm just trying to work out the base of this triangle. What else do you know? If this is a regular hexagon, what type of triangle is this? So I'm going to put this image up. You can see the type of triangle this is a isosceles, because if this is a regular hexagon, that side here and that side here is the same length, okay? So we can essentially put the line through it. So that is basically, it's just on a different upside down isosceles triangle. These 2 lines are the same, you're trying to work out that angle there. You know, with an isosceles triangle, if you know this angle here, you can take it away from 180 and you would know the sum of these 2 angles, okay? So in any regular hexagon, you know the interior angles is 720 divided by 6. So that means this angle here is 120 degrees. If you know this is 120 and you know the sum of the angles in this triangle here, the blue triangle, is 180, the first thing you need to do is 180 take away 120. 180 take away 120 gives me 60 degrees. That means this X, this one here and this one here are this one here and this one here are 60 degrees. So this one and this one are 60. If I show you on the bigger picture here, this one and this one are 60. Okay, We just want one of those angles. We just want x. If it's an isosceles triangle, the two base triangles are the same. They're equal, since these two side lengths are the same. So we do 60 divided by 2, which is 30 degrees. Therefore, x equals 30 degrees. Okay, GCSE style question on the screen. Have a read of the question, have a go. Once you have done that, come back to the video and we will go through it. Okay, it says the diagram shows 4 regular pentagons and work out the size of angle marked X. Well, first things first, if these are 4 regular pentagons, that means the base of each pentagon is the same. So in the middle, we have a square. So we have a square with 4 regular pentagons around it. You need to work out X. 2 angle facts, that main angle facts you need to know. Angles around a point add up to 360. So angles around this entire point add up to 360. Okay, we know if this is a square, that's a 90-degree angle. That's another angle fact. If you identify that as a square, which it is, this is 90 degrees. So in order to work out X, you do 90, add this one here, add this one here, and you then take all of that away from 360 and it will give you X. How do we work out the two interior angles in a pentagon? Well, you already know how to do this. All interior angles in a pentagon add up to 180 times 3, which is 540 degrees. And to work out one angle in that regular pentagon, you do 540 divided by 5, which is 108 degrees. Okay, so one interior angle in this pentagon, this one here and this one here, is 108. Therefore, if I just draw that on the side here, not very accurate. That one is 108. That one is 108. That one is 90. So I'm just drawing this bit here in a very rough sketch. So to work out X, we would do 108, add 108, add 90, take it away from 360, and therefore X is 54 degrees. You should show your full workings and annotations on the picture as you saw in the previous question. It's a 4-mark question. Okay, it's now time for you to complete some independent practice as set by your classroom teacher.